Hello everybody, this is Maurizio Martignano from Spazio IT and welcome to this video where we're going to talk about code pre-processing and code spelunking. Suppose we have a system like our example, the Crazy Fly system, where we have already performed static analysis and we cannot find really the reasons for something that is not behaving properly. And though we checked the code, we could not find any particular reason for this misbehaving, these errors. So we want to look for something deeper, something more difficult to find. So the first thing we have to do is to talk a bit about pre-processing and see what pre-processing is. Skip. Let's take a very simple example like this one where we want to check what is the maximum of two integer values. So we have this very simple C program where we take two values, A and B, we check what is their maximum and then we print the result. And in order to do that we have a macro, this max macro, which basically is this expression where we check if x is greater than y, and then in one case we select x or in the other we select y. Very simple, very simple. So we compile this example like this. And once it finishes, we make it run. Very simple, it works of course. But if we check this simple program, we have some code we have written. And then here at the very beginning we have this include statement where basically we include another file which is full of declarations. Okay, if you want to see what the compiler preprocessor does, how the compiler interprets this include statement and this defines and so on, we need to invoke the following command. So we call again clang -e and then define, and we get this output which is pretty long, and so we want to catch it on a particular file to be able to read it properly. So we do this, and then we can look at our file, which is this one of course. So the first statement includes the do.h has been expanded in this set of inclusion, a very long set of inclusions, where we have, as you can see, we have declarations, but we have also definitions. So there are pieces of code where we have some kind of functions defined. You see, this is a function with a beginning and an end. And our code, it's only at the end of this big file, and here it is. All the defines here, like value of A and value of B, have been replaced with the actual values. Then the macro has been expanded and called, and so this is our program. So what we see is that the code that goes inside the preprocessing phase of the compiler is not only our code, but is our code plus a set of additional code provided to us by the compilation system via the include files. So maybe the sum of the problems are not in our code, but are in this external code provided to us by the compilation system. So what we want to do, we want to be able to check also this quote-unquote external code provided to us, and we want to do that via the SAFe Toolset, via the SAFacilitator. So we start the SAFacilitator, the static analysis facilitator. Here it is, and let's see what we can do about this particular problem of understanding what happens at pre-processing level. So we load our crazy fly example. We open it and we look at our project. Okay, so the first thing we have to do is to create a directory which is not a child of the project directory, but is a sibling or somewhere else, where we will put all the preprocessed files, all the files preprocessed by the compilers, because this time we want to analyze not the original source files, but the files preprocessed by the compiler. So what we do is that, okay, we say okay here, we minimize a bit the SAFacilitator, and we go one level up, and we create a directory that will contain the expanded and exploded file, so we call it exp, like this. Okay, of course this directory is empty. So very simple. So now what we do, we take again the SAFacilitator. We take the application and we edit a bit our project. So what we have to say first is that we have a directory where we'll put the preprocessed files. So we specify that this crazyfly-exp, the directory we just created. So we selected it, so we're happy. And then we go to the files, it's okay, compilation is okay, the analysis. We're going to see that we want to enable the pre-processing because we want to see what the pre-processing does to our files and things like that. So we select this option, okay, and of course we say okay, and we save it as a new project as crazyfly_exp. It already exists, it doesn't matter because it's called it that way because it's working on expanded files that are produced by the preprocessing activity. So we save it. Of course we replace it. Okay, let's look again at the project. In theory, our project had all these analyzers activated. In fact, PCLint, CPP-check are not able to parse the output of the preprocessor. It's too complicated, too complex for them to be able to read it, to analyze it. So the only interesting analyzer is the CLang static analyzer, and CLang tidy is an improvement, is something more than the CLang static analyzer, but the real nature of the CLang tidy is the CLang static analyzer plus something that has to do with the style and the conventions in the code. So because we are going to check and look at the output of the preprocessor, Untitled cannot provide any additional information compared to the Silang static analyzer. So the only analyzer that is going to be active in this operation when the preprocessing is enabled is the Silang static analyzer. So even if we have a tick on all these analyzers, whenever we do preprocessing and we work on the preprocessed files, we are going to use only the Silang static analyzers. So, okay, what we have to do first is go back, save everything. We have to start the preprocessing activity. The first step will be to prepare the preprocessing. So we do that. And now we call the preprocessor on all the C files, on all the files that we have in the project. So we do this, preprocess sources. And it will take a while, and we'll see the results. So here we can see that the preprocessing has taken place, and we can see that now in this directory that it was empty, we have plenty of files now. Some of them are just the files copied from the project base file. Some others will be the C preprocessed files, and I'm going to show them to you. So if we go up to the root level, we can do this something like, we can check this particular file that is in the base directory, and this is the original one. You can see this is the original file, and if we go to its copy in the exploded directory, in the expanded directory, we have the same file, but it'll be a preprocessed files. So we can see we have all the preprocessed variables and defines and includes, and at the end we have our original file. So the preprocessing activity basically copies the base directory into the expanded directory and then preprocess all the sources. This is another option which could be useful. If we do this command, we can see what are the defines that are predefined inside the compilation system. Every compilation system has its own defines, and these are the defines of the compiler used for this particular project, the Crazyfly project, which is the ARM embedded compiler, the GCC embedded compiler for ARM. Okay. So now we can prepare the analyzers, which is of course only the Silang static analyzer. We can run the analyzers, which is again only the Silang static analyzer, and in this case the Silang static analyzer is going to check the files that have been produced by the processing activity, not the original files. So we wait for this analysis to finish, and then we resume our video. I stopped the execution of the analyzer because I on purpose made a mistake to show you something which is very important. Okay, if we look inside our expanded directory, I would have expected to see here files of the type plist produced by the static analyzer, but I can't find any of them. If I go to the original project directory, and if I look for those files, I find them there. So something wrong is happening, and so first we remove these files. What has happened is that we have saved the project, we have saved all this stuff, but we didn't generate the proper compilation command database for the static analyzer. So what we have to do is not only to save the project as crazyfly.xjson, something that we're going to do right now, again, to be sure. But what we have to do also is to save the project as compile commands file. And we save the project as compile commands file, not in here, but in the expanded directory. So this is very important. We have to do this. So we now prepare the analyzers again, and then we run the analyzers again. And now if we go into the expanded directory, and we look for files of typeplists, we see that now the proper files are created in here, in this directory. So we wait for the static analysis to finish, and then we see the results. Once the static analysis has finished, we can post-process its results. And now we have the possibility of having all these results included, converged into a SonarQube project. So this is what we're going to do. We prepare the SonarQube script and we check it for a moment. So what we can see is that the original project name, was of course just Crazyfly, has been modified in this case by the SAFacilitator into Crazyfly Exploded, and the same for the key and the same for the version. This exploded keyword that has been added, this exploded suffix that has been added, will allow us to differentiate the project, the original project, the Crazyfly project in SonarQube, from this project which is similar but is not exactly the same because it has been done analyzing the pre-processed files. So we'll be able to differentiate and to compare the two projects from within SonarQube. So we close this file and we start the insertion of the analysis results into SonarQube. So we do it from here. So we run Sonar Scanner, and again we wait for the execution of this conversion and inclusion of the results into the SonarQube database. Well, after a while, the insertion of the analysis results into SonarQube is finished, and as we can see, it took some time, and we can see the results into Sonar. So we have this Crazyfly Exploded project. For your convenience, in Spazio IT demo server called sonarsrv.spazioit.com, I have already inserted both projects, the original Crazy Fly project and the Crazy Fly Exploded, so that we can compare them. Okay. As you can see, the code base is bigger in the Crazy Fly Exploded. Why? Because we have also the included files there. And the bugs are less in the exploded version. And why? Because we're using only a single static analyzer and not all of them. So we can try to compare the two projects. So we open Crazy Fly on one window and we open the Crazy Fly Exploded in the other one. Then we look for the issues here, and we look for the issues here, and in here we go into the tags and we select especially the one flagged with core. These are the one identified by the Clang static analyzer. So we take this particular core issues and we do the same on the exploded project. So we take the tag and we take the core. As we can see, the number of issues is different, and in the original project we have only 24 issues, and in the quote-unquote exploded projects we have 49 issues. Okay. Now, some of them are exactly the same. Some others, like for instance this one, are the result of the explosion, and if we see at the expanded code, if we check it, we see that here there is already a protection, because you see, if this condition is true, then this assert fail is triggered, and then we know that we have an issue. Okay, this is not recognized by the static analyzer, so the static analyzer has this particular kind of path that says pxq is initialized here, then assuming that psq is null, okay, but this is already checked here. This is already checked here. So this assumption on point 2 will never be true. So this additional issue is invalid. For the Crazy Fly project, all additional issues, which are 49 minus 24, so lots of them, all of them derive from this type of construct, from this assert fail thing. So basically, having analyzed the exploded files didn't bring us any additional information of any value. This is a particular case because actually the Crazy Fly project is pretty good, and because also the source code contained in the include files and the use libraries it's okay. It hasn't got any issue. In some cases, on the contrary, there may be problems and issues also in the code contained into the expanded files. The only way to verify the actual existence of problems is issue is exactly this one, is to check, say, the original files and the issues we have in the original files, to check them against the expanded files and the issues we have in the expanded files. And with this comparison, our video on code spelunking and analyzing the pre-processed files, the expanded files, is finished. Thank you very much for your attention.